Okay, so we are on page, sorry, I zoomed in before I started the video. This is the third video. We are on page 682 and we're going to talk a bit about the forest plots that you see here. Quick overview, there's multiple forest plots here. As you can see, they gave you multiple. Generally in a forest plot, they will have where you see says study, they'll put the author, the main author of the study, and then multiple studies going down this left side. In this case, because they couldn't compare this study to the others, it's by itself. So let me use this first as an example just to go through what you're looking at in the forest plot, and then I'll go back to the overview portion of it. With that being said, I'm going to zoom back in because I want you to be able to see this well. So let's just take a overview look at this from just this one study. In this case, this forest plot only represents DeLuca's article from 2002. So they have this study here. You have N for the number treated for the treatment group, which they showed the mean and standard deviation for, and then the number treated for the control group, which they also showed the mean and standard deviation for. Common statistics that you've seen. On this side, we have the weight, which I'll talk about what that is, and then the SMD, and I'll talk about what random means again, with a 95% confidence interval. Now, just as a reminder, earlier I kept saying standard mean deviation, totally something different. I apologize, way too many stats in my head, but this SMD actually, again, stands for standard mean difference. Okay, and just as a reminder, the standard mean difference it's the difference in mean outcome between groups divided by the standard deviation of outcome among participants. So many terms that look alike, so I apologize. I don't want to confuse you anymore. This standard mean difference is a common statistic that we use in meta-analysis. Now let's talk about just what this means. We have these axes here. You have a horizontal axis and you have a vertical axis. This axis or axes is what we call the null effect, and it's always in between the two groups. In this case, it's between a control and an intervention, or it could be between an exposure and an outcome, or if there are, instead of a control, there was another treatment group or another intervention. It could be intervention and another intervention, or treatment versus treatment. That line, null of effect, has to be between the two groups to show, because there's no association. So it has to start at 0. And then from there, you will see something like this green box with this line going through it on one side or the other. And sometimes it may fall in between that 0, showing no effect at all. But in this case, since it's on the side where it says favors the CIMT group, that means that this study showed that it favored this intervention versus the control. Okay? This little green box is what we call the point estimate. And the line going through it is what we call the confidence interval, which you're very familiar with. That box is not always green. That line is not always that short. It depends on the confidence interval for that study. And the size of this green box depends on how large the study is. Now, if there was a case where or I shouldn't say if there was a case, but if this had multiple studies, I'm going to go down to the next one, such as this, you'll see more than just one. Again, they still compared these somewhat separately, so this isn't the best example. Let me see. All of these were compared separately because of the heterogeneity. But you would see multiple of these boxes all the way down. Depending on what the study favored, some may fall on this side, which if this study had articles that favor the control, there might be a few studies that fall under the favors control side, and there might be a few more that fall under the intervention side, and there might even be some that might fall right in the middle because there was no effect. But in this case, going back up to the one, we're just looking at that one study. It favored the CIMT group or the intervention side. Okay, great. So that's the gist of that. Now, The reason this says test for heterogeneity, because remember, we utilize meta-analysis so that we can test for variability within all of the studies. And we're looking to see if these studies are similar or if they are not. And if they are not, what's the reason they're not similar? Is it by chance, or is it really some heterogeneity from the outcomes to the methodology to the statistical tests computed? We're looking for the reasons why. Okay. I lost my train of thought. I'm sorry. So that's why we have the forest plot. So now again, we have the study, the number of people treated in this the treatment group, which this treatment group is the CIMT, the number treated in the control group. The statistic used to compare it, or the statistic used to analyze it, was the standard mean difference, and they used a 95% confidence interval. Now let me talk a little bit about what this random means. Okay, we have different models that we utilize to test for effect size. Effect size, we've talked about this previously, is important because in all, when we're looking at generalization, we want to know what's the overall effect of utilizing this intervention and how much effect does it really have. Okay, so if all the studies that were looked at in this study had the same amount of effect size, right? Because studies are tested for separate effect sizes, then you could just pretty much calculate the mean for the effect size if they were all equal. But a lot of the time study effect sizes are not equal, so we can't compute something that doesn't exist. If they're not all the same, we can't just magically make them all the same and make up numbers. So we have to use different models. Okay, a random model takes the true effect, or the random effect model, sorry, I wanted to make sure I'm getting that out clearly, allows us to compute for effect sizes that are different, meaning a true effect size can vary per study. If this said fixed, where it says random, if it said fixed effect model, that means that they all share a common effect size. So there's only one true effect size shared by all the studies looked at in this study, meaning they all had the same effect size of 0.80. But in this case, that may not happen. If you have studies that may have an effect size of 0.60 or studies that have an effect size of 0.80. We have to assess for that. So they're using random because each study has a true effect size that can vary. That's what that random means. Now, with that being said, let me just slide on over to weight. This has 100% because only one study is looked at in this forest plot, and it's being assessed by itself. Again, because effect sizes can differ, we have to assign weight per study. Meaning, if a study has more information, we're going to assign that more weight. Meaning that when we do calculations, we're going to take this study into a bit more consideration for numbers wise because there was a lot more available to utilize than maybe another study. That's what that weight means. In this case, it's 100% because there's only one study being looked at. Now, this SMD random 95% that you see again here, that you see here and down here is the same thing that we're looking here. They're just giving you a number version to look at it versus a graph version. Now, they did not test for heterogeneity because there's just this one. And again, they are testing for overall effect. And then they give you a p-value. I don't think I talked about the black diamond. I'm sorry. So The black diamond that you see here is the, I'm sorry, I'm looking for the right word. I'm just going to stick with diamond because that's mostly what we call it. But the black diamond essentially represents the point estimate, that's this guy, and the confidence interval, the line that's going through it. When you combine and average all the individual studies that are viewed in a forest plot together, but in this case, this black diamond only represents this one study because that's the only study, okay? So again, the diamond represents the point estimate and confidence intervals, all of these. When you combine and average all of the individual studies together, it represents this. But in this case, it only represents that one study because that's the only study that it's looking at. Now we go down. This is something else that they were assessing for. And then they give you, technically this is it's the same study, but a continuation of the same study. So here we have post-treatment 0 to 2 months, and then they did follow-ups from 0 to 6. Again, they cannot test for heterogeneity because they're done separately. The weight, again, if that makes sense, is 100% because those studies are only being looked at by themselves. You have the standard mean difference again, with the confidence interval being displayed here as a number, and then the same thing over here where it's being displayed as a graph version. This green box that you see again is the point estimate with the confidence interval line, and then the diamond represents what would be the average of all the individual studies, but again, it's just that one. That is a forest plot. So to just re-summarize what we see here, you have horizontal line on you have each horizontal line on a forest plot that represents the individual study, with the result plotted as a box, the little green box, and the 95% confidence interval, which is a line. The implication of each study falling on one side of that vertical line, which is our null of effect, lies within the 95%. Of the vertical line depends on the statistic being used. This is statistic being used, and it's telling you which side it favors. So in this case, this study also favored the CIMT. If the individual study crosses that vertical line, it means that the null value lies within the 95% confidence interval. That implies the study result is in fact the null value, and therefore the study did not observe any statistical significance between the two groups. So if it falls on this, there was no difference between the two groups. The diamond at the bottom that you see for each one will represent all of the individual studies combined together in average, and then the horizontal points the horizontal points of the diamond are the limits of the 95% confidence intervals. So the points, boom, 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 boom. Okay? Let me go down and see if same thing. This study was also looked at individually, and they could not test for heterogeneity. See, not as difficult as we thought it was. Sometimes it just takes working through it. I'm going to go back up just to make sure I didn't miss anything. So from there, we do the discussion. And the discussion should help you. If you're still questioning whether there's heterogeneity, which there clearly is in this study, heterogeneity. If you're still struggling going through the data analysis and then looking at the graphs, the discussion should be able to kind of help you wrap up some of that information.